So, good morning, friends. Today, we are going to discuss about shear force and bending moment diagrams. That means fundamentals pertaining to shear force and bending moment diagrams. And also, we can make a note of various types of beams and also various types of loads acting on beams. And finally, we have to note down some basic rules which are very, very essential for constructing SF and BM diagrams. So SF for shear force and BM for bending moment. So in short, they are referred to as shear force and bending moment diagrams. So friends, here basically we have to note down the basic definition of this term referred to as beam. So we talk about different types of beams. Different types of beams are available for construction of structures. So mostly we deal with cantilevers and simply supported beams. So therefore, first of all, we have to make a note of this definition that is referred to as a beam. So this definition, it is given in this second slide. So it is defined as, or any beam is a structural element which has capacity to resist loads applied laterally to the axis of the beam. So this is the basic definition. So it is an element that is used for construction of structures. So it's called as structural element. And several loads will be acting on the top of the beam in vertical direction and mostly in downward direction. And these beams are arranged in horizontal position, and therefore loads will be acting in vertical direction. So this element, the beam, must have capacity to withstand all the loads or different loads acting at different points on the beam. So we can see the second sentence. So it is defined as a member which is capable of receiving loads at different points without any kind of failure or collapse. So this is the actual meaning of this definition. So it has capacity, it should have capacity to withstand, different loads acting at different points. And at the same time, it should not result in any kind of failure. So unless it is capable of receiving and withstanding loads at different points, so it will not be in a position to avoid the failure. So without any kind of failure, so it should have capacity, or it must be capable of receiving loads acting at different points on the beam. So friends, this is the definition of this term that is referred to as a beam. So different loads will be acting in perpendicular direction. Beams will be arranged in horizontal position, and different loads will be acting in vertical direction. That means they will be acting in perpendicular direction at different points on the beam. So this element must be in a position to withstand all the loads acting at all the points or different points on the top surface of the beam. So this is the about the definition of a beam. Friends, we have different types of beams are available. So these beams are basically they are classified into four different categories, namely cantilever, secondly simply supported beam, third one fixed beam, and finally the last one called as continuous beam. Now in some cases this beam will be fixed at one end, and it will be free at another end. So if any beam which is fixed at one end and free at another end, that is called as cantilever. So generally the left end of the beam will be in position, and the right end of the beam, mostly generally the right end of the beam will be kept in free position. So therefore one end is in fixed position, and another end of the beam is kept in free position. So therefore it is referred to as a cantilever. The second one is called as simply supported beam. So a beam which is provided with supports at the end points, it is referred to as simply supported beam. That means both the ends of the beam are provided with some kind of supports. So the left end of the beam is provided with one support, and similarly the right end of the beam is also provided with another support. So the ends of the beam are provided with supports for withstanding loads acting on the beam. So therefore it is referred to as a simply supported beam. And the next one, it is called as fixed beam. Now in this case, as the name itself implies, the beam is kept in fixed position. That means the beam which is fixed at both the ends both the ends of the beam are fixed in position. That means they are kept in fixed position. So if that is the case, it is referred to as a fixed beam. So there is a small difference between cantilever and a fixed beam. So in the case of cantilever, one end of the beam is in fixed position and another end of the beam is kept in free position. But whereas in the case of a fixed beam, both the ends of the beam are kept in fixed position. So that's why it is referred to as a fixed beam. As next one, it is called as continuous beam. So here, just like a simply supported beam, this continuous beam is provided with supports at the ends of the beam, and in addition to end supports, several other supports are provided throughout the length of the beam. That means across the length of the beam. So, in addition to end supports, if the beam is provided with several supports across the length of the beam or along the length of the beam, it is referred to as a continuous beam. So there are some similarities and differences between cantilever and fixed beam. Similarly, there are some similarities and differences between simply supported beam and continuous beams. And friends, lastly, the last one that is called as overhanging beam. Now, in some cases, the length of the beam is extended beyond the end supports. So it so happens that the length of the beam will be extended beyond the end supports. That means either at the left end of the beam or at the right support of the beam or on the both the ends of the beam. So if that is the case, its extended portions are called as overhangs. Extended portions are called as overhangs. Therefore, it is referred to as overhanging. So, in this we have again different varieties. Beams with one overhang on right side and beams with one overhang on left side. And also we have beams with two overhangs on both the sides beyond end supports. So therefore, overhanging beams are again subclassified into three categories. Beams having overhanging portion on right side and beams with overhang on left side. And finally, we have beams with overhangs on both the sides. So friends, overhanging beams, they are classified, depending upon the arrangement, they are classified into three different categories. Beams with overhang on right side, overhang on left side, and overhangs on both the sides. So depending upon the requirement, these different arrangements will be made in different situations. So broadly, basically, the overhanging beams, they are classified into three different categories. So friends, this is about the types of beams. So we have to note down the definition of the beam, and we have different types of beams: cantilever, simply supported beam, fixed beam, continuous beam, overhanging beam, types of overhanging beams. So different beams are used in different situations. So mostly we get the problems on cantilevers, simply supported beams, and sometimes we get problems on overhanging beams. So we have to do the calculations, we have to make the calculations and find out the values of shear forces and bending moments. And finally, we have to construct shear force and bending moment diagrams. So here we talked about the classification of beams used in different situations. So in the beginning of the session, we were talking about loads acting on the beam. So they are classified into two different categories, namely point loads and secondly uniformly distributed loads. Now here, this point load, it is also called as a concentrated load. Here the entire load is concentrated at one particular point on the beam. So that's why it is called as a concentrated load. In other words, the entire load is acting at one particular point on the beam. So therefore, they are also called as point loads. Now, these point loads are denoted by capital W. So capital W is the letter that has to be used for indicating point loads, either on cantilevers or in simply supported beams. So in all these cases, capital W must be only used for indicating the magnitudes of point loads, and they are expressed in terms of newtons or in terms of kilonewtons. In some problems, they are expressed in terms of newtons. Some problems, they are expressed in terms of kilonewtons. So we are following SI system. So therefore, point loads always, to be expressed either in terms of newtons or in terms of kilonewtons. And finally, in some cases, only one point load will be acting on the beam, and in some cases, we come across two different point loads. Some cases we may come across three different point loads or even four different point loads. So different loads to be expressed in different forms. So W1 must be used for indicating the first point load, W2 for indicating second point load, W3 for indicating third point load. So different, numericals can be used for indicating a different point loads acting on these beams. It can be a cantilever or it can be a simply supported beam. Some places we come across only, one load is acting on the beam, and in some places we come across several loads acting on the beam. So if that is the case, W1 to be used for indicating first load, W2 for indicating second load, and so on and so forth. In general, the point load capital W is, in general, capital W is used for representing the magnitude of points. So the next one, it is called as uniformly distributed load. Simply, it is called as UDL. It's abbreviated as UDL. Now, this load is distributed evenly or uniformly for a certain length of the beam or for the entire length of the beam. So the entire load is distributed uniformly for a certain distance or for total distance. That's why it is called as uniformly distributed. So the the distribution of load is even. It's evenly distributed. Distribution of load is uniform. So that's why it is called as uniformly distributed load. So it will be acting, at the rate of unit distance. So small w is used for indicating uniformly distributed loads. And these loads, they are expressed either in terms of Newton per meter or can be expressed in terms of Newton per millimeter, can be expressed in terms of kilonewton per meter. Finally, can be also expressed in terms of kilonewton per millimeter. So different kinds of figures will be, these units will be given in different problems. We will take it as it is and, do the calculations, SF and DM calculations. So there are 4 ways of indicating the units of UDLs: Newton per meter, Newton per millimeter, kilonewton per meter, or kilonewton per millimeter. So in general, its UDLs are expressed in any one of these units so far as SI system is concerned. Now, friends, in some problems we may come across, several, UDLs. That is the case. Small w1 can be used for indicating first UDL, small w2 for second UDL, so on and so forth. Different notations can be given to different UDLs, acting on the. So friends, we have only 2 different types of loads. We will be dealing with mostly we'll be dealing with 2 different types of loads. The first one called as a point load. The second one referred to as a uniformly distributed load. Capital W to be used for indicating point loads expressed in newtons or in kilonewtons. Small w to be used for indicating UDLs expressed in Newton per meter, Newton per millimeter, kilonewton per meter, or kilonewton per millimeter. So friends, these are the units. So we have to remember the definitions. We have to remember the, units, and also we have to remember the notations. So all these, factors are very, very important. Remembering definitions, remembering notations. That is capital W for point load and small w for UDL, called as notations. And remembering units, Newton, kilonewton for point load, Newton per meter, Newton per millimeter. So all these things for UDLs. So friends, definitions are important, notations are also important, and lastly, units are also, very, very important while dealing with these topics. And as mentioned in the first statement, these UDLs, sometimes this UDL will be acting for the entire length of the beam, and in some cases it will be acting only for a portion of the beam. First portion of the beam, or it can be second portion of the beam, or it can be the last portion of the beam. So the situation will be different in different cases. So in general, UDLs will be acting. In some cases, UDLs will be acting for the entire length of the beam, and in some cases, UDL will be acting only for a portion of the beam. So this is the first one is called as UDL, and the second one, which is acting for a portion of the beam, that's also referred to as an UDL. So any load which is distributed evenly or uniformly, it should be called as an UDL. So friends, this is the difference between point loads and UDLs. And we have talked about the arrangement of the beams and direction of loads acting on the beam. So loads will be acting vertically in downward direction, and beams will be arranged in horizontal position. So beam will be arranged in this position, load will be acting in this direction. So it is said to be acting in perpendicular direction as mentioned in the slide. So friends, we talked about the various types of the beam, and this is a wonderful figure, a wonderful thing which indicates the arrangement of various types of beams. So the first one, we can see the arrangement of a cantilever. So this cantilever is fixed at one end and it is free at another end. So this beam is fixed at one end and it is free at another end. It is called as a cantilever. And this beam is provided with supports at ends. This is the left end of the beam and this is the right end of the beam. And both the ends of the beam are provided with supports. Supports are provided at both the ends of the beam. So therefore, it is called as simply supported beam. Now here you can see the arrangement of a fixed beam. In this case, both the ends of the beam are kept in fixed position. So here only one end is in fixed position. That's why it's called as a cantilever. But here, both the ends, this end as well as this end, both the ends of the beam are kept in fixed position. So therefore, it is called as a fixed beam. And now coming to this, in addition to, end supports, Other additional supports are provided across the length of the beam. So they are called as the first one and the last one called as end supports. This is similar to the supports provided in the case of simply supported beam. But in addition to end supports, several other supports are provided. One and two, several other supports are provided across the, along the length of the beam or across the length of the beam. So that's why it is called as a continuous beam. So here supports are provided only at the ends of the beam. That's why it is called as a simply supported beam. Whereas in this case, in addition to end supports, several other supports are provided along the length of the beam. So therefore, it is called as continuous beam. And finally, we can, friends, we can see the arrangement of OH beams. So this can be called as one support and support, just like a simply supported beam. This is called as the left end support, and here we have the right end support. So they are referred to as end supports of the beam. Now the length of the beam is getting extended beyond this support, and also at the same time it is also getting extended beyond this support. So therefore it is called as overhanging beam. So if the length of the beam is extended beyond end supports as shown in this figure, then it is called as overhanging beam. In some cases of overhanging, this is extension will be done only in the left hand side. In some cases we see the extension only on right hand side. That is one overhang. In some cases, in such cases, we see extensions on both the sides. This is the extension on the left side of the beam, and this is the extension on the right side of the beam. So all these, beams are referred to as overhanging beams. So this is the beam which is provided with the extensions on both the sides. So this is called as a overhanging beam with two extensions. So in the previous slide, we were talking about the types of overhanging beams. Overhanging beams with one extension on right side, overhanging beams with one extension on left side, overhanging beams with two extensions, overhanging beams with extension on two sides. So this is the example of third category. So friends, we have noted down the definitions, and here we have wonderful figures for understanding these definitions. This beam fixed at one end and it's free at another end, called as cantilever. This is provided with two end supports, simply supported beam. And in addition to end supports, it is provided with additional supports. It's called as a continuous beam. This is fixed at both the ends. It's called as a fixed beam. This is provided with overhangs on both the sides, on the left side of the beam as well as on the right side of the beam. So it is referred to as overhanging. So these figures, wonderful figures, are very, very useful for understanding the definitions of different types of beams which we have discussed in the previous slides. So friends, here we can see the examples of point loads and uniformly distributed loads. So this is the way of, these are the ways of indicating point loads. It can be a cantilever or it can be a simply supported beam. So this is the way of indicating point loads, and this is the way of indicating uniformly distributed loads. So proper indication of loads acting on beams, it's also very important while preparing, diagrams, while preparing loading diagrams. So friends, they are called as loading diagrams. So these will be given in the examinations. And using these diagrams, we have to make calculations. We have to prepare equations and make calculations. And with the results, we have to construct shear force and bending moment diagrams. So in the beginning, we were talking about the types of loads. So we have to indicate the various loads acting on the beam. This is the way of indicating point loads, and this is the way of indicating uniformly distributed loads. So friends, here point load is acting at the center of the beam, and here UDL is acting for the entire length of the beam. So depending upon the data that is given in the problem, we should be in a position to construct loading diagrams correctly as per the data given in the problems. So friends, we have to note down the definitions of shear force and bending moments. So this is given in this particular slide. So shear force, it is defined as algebraic sum of vertical forces acting at any section of the beam. It can be, on the right side of the section, or it can be on the left side of the section. But mostly we will be considering all the forces falling on the right side of the section, and we will be taking the sum of all these forces, of course with positive and negative signs, and based on that we will be calculating shear forces at acting at different points on the beam. And secondly, this concerned forces multiplied with corresponding distances from these sections. So will give us the value of bending moments. So total moments of all the couples are moments acting on the right hand side of the section. So that gives us the values of bending moments at different points on beams. So some more information is given. So these diagrams, about diagrams, analytical tools used for structural analysis, for performing structural design by determining the value of shear force and bending moment at any given point of a structural element, generally referred to as beams. So friends, we can actually talk about SF and BM diagrams in this particular slide. So as I've already told you in the beginning of the section, this SF diagram, it is prepared by taking all the values of shear forces at different points on the beam. So naturally, this diagram will be indicating the values of different shear forces acting at different points on the beam. And similarly, bending moment diagram, it is prepared, it is obtained by taking all the values of bending moments at different points on the beam. So naturally, it will be indicating values of bending moments at different points on the beam. So friends, as the name itself implies, SF diagram will be indicating the values of shear forces at different points on the beam. And similarly, bending moment diagram will be indicating the values of bending moments at different points on the beam. So you will be preparing loading diagrams, will be making calculations, will be getting the values of shear forces and bending moments. Using these values, will be constructing, all these diagrams. So friends, here allocation of symbols, very, very important. So allocation of symbols for loads acting on the beam and also for these movements of the beam. So generally positive sign, positive symbol must be used for all the forces acting in downward direction, and negative symbol must be used for all the forces acting in upward direction. And similarly, positive signs, positive symbols must be used for all anti-clockwise movements, and negative symbols to be used for all the clockwise movements. So, and friends, secondly, downward forces will result in clockwise movements. If a force is acting in downward direction, the beam will have a tendency to move in clockwise direction. And if a force is acting in upward direction, generally the beam will have a tendency to move in anti-clockwise direction. So friends, downward forces will be resulting in clockwise movement. Upward forces will be resulting in anti-clockwise movements. Now we have to take a positive symbol for downward forces and anti-clockwise movements. And we have to use negative symbols for upward forces and clockwise movements. But downward forces will be resulting in clockwise movements, and upward forces will be resulting in anti-clockwise movements. So friends, if the value of CF is positive, the value of bending moment will be negative. And if SF value is negative, then the moment value will be positive. So friends, these are the basic rules to be applied while allocating symbols for shear forces and bending moments at different points on the beam. So here we have little information regarding construction of SF and BM diagrams. And friends, in both the cases, whether it is SF diagram or BM diagram, so we have to take a line, horizontal line, that is called as a baseline. And naturally, positive values must be plotted above the baseline, and negative values must be plotted below the baseline. So all the positive values will be coming above the baseline, and all the negative values will be coming below the baseline. So this rule has to be used for constructing SF diagrams, also for constructing bending moment diagrams. So positive values of shear forces will be coming above the baseline of the shear force diagram, and negative values of shear forces will be plotted below the baseline of the SF diagram. And similarly, positive values of bending moments will be coming above the baseline of the BM diagram, and the negative values of bending moment will be coming below the baseline of bending moment diagrams. So friends, these are the simplest basic rules to be remembered while preparing shear force and bending moment diagrams. And friends, here we have some information regarding the shapes of SF and BM diagrams. So for point loads, straight lines will be coming at SF diagram, and inclined lines will be coming at BM diagram. So for point loads, straight lines must be used at SF diagram, and inclined lines must be used at BM diagram. And similarly, in the case of UDLs, inclined lines will be coming at SF diagram, and parabolas will be coming at BM diagram. So friends, in the case of point loads, we have to remember these two, conditions while preparing the diagrams at point loads. And we have to remember these two conditions while preparing bending moment diagrams at UDLs. So in the case of point loads, we have to use straight lines at SF diagrams and inclined lines at BM diagrams. In the case of UDLs, we have to use inclined lines at SF diagrams and parabolas at BM diagrams. So friends, these rules are also very, very important while doing the construction of SF and BM diagrams. So friends, finally we have come to the last slide. So these are the general rules to be followed while solving the problems. The length of the beam must be divided into different portions for writing SF and BM equations. So we have to do it separately for each and every portion. So the beam is divided into 2 or 3 portions. Portion AB, the portion BC, the portion CD. Now we have to write SF and BM equations for different portions separately. So this is the first thing to be followed for, to be followed for writing SF and BM equations. And secondly, we have to start from the right end of the beam, and we have to proceed in reverse direction for reaching the left end of the beam. So that is given in the second sentence. And thirdly, fixing of limits. That is very, very important, friends. Fixing of lower limits and upper limits for each portion is very, very important. So this is done by taking distances from the right end of the beam. Now we have to substitute these limits in the general SF and BM equations, that is in the corresponding SF and BM equations of the corresponding region. and we have to get two sets of values for shear force and bending moment values, and using all these values naturally we'll be in a position to construct shear force and bending moment diagrams. And finally, friends, this considering a section, that's very important. So that each and every portion we have to consider a section XX at a distance of X meter, at a distance of X meter from the right end of the beam. So we have to consider the forces acting only on right end of the beam for preparing the SF and BM equations. So this way we have to write SF and BM equations for all the portions of the beam and fixing the limits, lower and upper limits for each and every portion, substituting these values in corresponding SF and BM equations and getting the results, and preparation of SF and BM diagrams using these results. These are the things to be done while solving problems on this chapter. So friends, thank you very much for watching the session.